Good day, STEM class. Welcome to our Physics 1 laboratory class. And today we are going to perform an experiment that is about measurements, that is about precision measurement. We're going to call it as lab experiment number 1. And we have set some kind of an objective for today, and we will be needing some materials today. Now, among the materials that we'll be needing today is, of course, one is a tiny box like this. No? So this is a box of an ink. So you can prepare this one. You'll need this discarded part. No? We usually throw this. This is one of our leftover for our tissue paper. So this is the one that we use on our kitchen probably. And then you'll need a ruler, no? And maybe another material that you're going to need is the protractor. We will have the summary of those. So for this for these 4 materials, I want you to prepare them ahead, no? So you will need to prepare them ahead of time, no? Before you perform this activity. I'm going to share this time now the activity that we will be having, no? And so that we will have a clearer picture of what we are going to do today. So again, the activity is about our experiment number 1. And our experiment number 1, again, as what we've seen here, is precision measurement. The goal or the objective of our experiment is to determine the factors that are necessary, no? Or what do you need, no, to achieve precision measurements. And we will do that, one, by the verification of the value of pi. We know that the value of pi, the accepted value of pi is 3.1415. We will try to verify that. Then number 2 is the verification of the Pythagorean theorem. That's a very common mathematics principle. Now, the materials, again, that we need, we have to use 4. So here are the sets of materials. So you can either use a paper tape, anything that does not stick. So you can use any kind of tape as long as it does not stick. And then you can also use or either use a cut piece of paper. No? Make sure that the length of this paper is enough to be wrapped around our cylindrical pipe later on. No? Okay, so moving on. So if we are going to get the very first thing that we are going to verify in the activity, so we are now going into the procedure of the activity. So the very first part of the procedure, so you are going to get the cylindrical pipe, that you prepared ahead of time, and then you're going to mount it or place it on top of the table. And what are we going to measure here? We are going to find how long is the diameter of our cylindrical pipe. So to do that, so there's by the way, a tool that we use in the lab. We call it the vernier caliper. But we don't have a caliper here, so we are going to improvise, and instead, as what I've said, we will squeeze this cylindrical pipe in between the 2 small boxes, the ink boxes that probably you have there in your house. So you're going to put this now, the cylindrical pipe in between. And the reason why we squeeze this is that we know that when we remove this pipe away, the distance between the 2 boxes will now be equivalent to our diameter. So to be able to know that distance, what tool are we going to use? Okay, so you're correct. We are going to use a ruler. So the ruler is needed to measure the distance between the 2 boxes. Now, to be able to gather, you have to gather 3 different measurements. All that we do to be able to get 3 different measurements is to rotate this into possibly 3 different positions for this cylindrical pipe. Or you can probably invert it and measure the other end. So you have to have, again, 3 different measurements for your diameter. You have to record it. And the recording should be in centimeter. So in the table for the template, no, the template that you have for your laboratory experiments, you have here 3 trials for the measurement of the diameter of the pipe. No? So based on the previous diagram that we show, you have to record 3 different values for our diameter. And then again, all the units must be in centimeter. No? Again, now having recorded the diameters of the pipe in centimeter, we are now ready to next measure the circumference. No? Again, who can remember the term circumference? Circumference is the distance around the circle. No? So if you try to go to the next step, no, you'll see that in measuring the circumference of that same cylindrical pipe, no? So we are going to measure the distance around here. And since this is curved, you will need probably a piece of ruler, of course, no, later on. But since this is curved, you need some kind of a paper tape or a piece of paper. No? So a paper tape that does not stick, no? It's not it does not stick here. And no, or if that's not available, you can use another kind of paper. No? Now this is now used, no, and we are going to wrap it, no, in 3 different sections of this pipe, no, to be able to get 3 different diameters, no, or circumference. So this one will now go, no, and we are going to wrap our cylindrical pipe now, no? And now the cylindrical pipe has been wrapped with this paper, and we realized that the ends earlier, no, that does not that is not connected, are now overlapping each other, no? And that's the portion where we are going to use a ball pen, no, to mark those ends that meet. No? Now again, these ends that we are going to mark will now serve as the circumference of our pipe. No? But again, we are going to get 3 values. So maybe one value will be taken from the top, no, of the pipe. Then another one will be measured in the middle. And then maybe probably another one will be measured at the bottom. So we will use the ball pen now to draw a line, mark a line here that overlaps, no, on the paper, and then spread out the paper, and we have now to measure that length. So supposing these 2 marks here are on the piece of paper, so we will get that the distance of these 2 markings on the paper, and now this one serves as your circumference. Now again, the circumference is measured in centimeter. No? So you will record 3 values of circumference. Now for each of these values, the diameter and the circumference, an average value has to be calculated. No? So the average is simply, no, taken by simply adding all these values and dividing it by 3. No? Then you'll have your average value. No? So one average value for the diameter and another average value for the circumference. No? So that's the part for our, no, verification of pi. Now for the Pythagorean theorem activity, the activity will need, no, you to construct, first of all, a right triangle. No? Now the right triangle is drawn by simply drawing 3 sides of a triangle and making sure that this angle here, no, one angle of the triangle is 90 degrees. No? It's right, no, or 90 degrees in measurement. Now, how do you assure yourself that you're going to get a 90-degree angle? Of course, you need your protractor to measure this angle exactly to be 90. No? All that you need to do is to measure these ends here. No? Depending on your group must have the same lengths. No? You must agree to have the same lengths. And then, once you draw now your right triangle, then you can begin to get the measurements for side A. You get the value there in centimeter. measure also side B, and then also measure side C. No? So this third side, we call this as the hypotenuse of our triangle. So since we use a ruler here, then all the values now will be recorded in our table. No? So the first value, side A, no, in centimeter is recorded in this part, side B, and then the hypotenuse of our drawing that was using a ruler, no, it will now also be recorded here. So this is the measured length of your side C. No? Now, you're going to use the Pythagorean theorem now. And again, the Pythagorean theorem is also written in this way, that the square of the third side or the hypotenuse is equals to the sum of the squares of the two other sides. No? So if you are going to get the value of C, if you know A and B, then you'll have to get the square root of the squares, no? The sum of the two squares, and then you'll get the computed value of C. No? So we are going to use this formula to solve this column. We call this as the computed length of side C. Do you see this one? So the computed length will now be using the formula. But where will we get the values of A and B? We will base it on our measured value. So from the measured value, we put it in our formula for A and for B. But for letter C, the third side C, in this table, we'll have to compute. So we have now two different values of the third side. One which is measured using a ruler, and one which is measured or solved using the formula of the Pythagorean theorem. Now, in all of our experiments, or in both of our experiments for the verification of the value of pi and the verification of the Pythagorean theorem, we are going to compare the percent difference. And the percent difference is, of course, the difference in our computed value minus the experimental value or the measured value all over the computed value. No? And if you get the difference and you divide it by this number and multiply it by 100%, then you'll get the percent difference. Now, the formula is written in your laboratory experiment template. No? So you can refer to that for the formula of the percent difference. No? You're going to get also the percent difference for your pi value. The computed pi is based on the formula of the circumference over the diameter, whereas the accepted value of pi is the value that we already know, which is equals to 3.1415. And then when you get the difference of the two and divide it, now then you'll get your percent difference. Okay, so for your activity, these are your procedures. Okay, hopefully you have the procedure is clear, but there's also a way of refreshing it by reviewing the activity. No? So you can always refer to the activity again. No? Okay, so God bless in your procedure.